Hi everyone, this is Darshan Senthil, and in this video we shall be talking some more about logarithmic differentiation. So logarithmic differentiation is not as much a method of taking derivatives as it is a sort of way that makes taking derivatives easier. It's just a little trick that we use to make complicated derivatives a lot easier for us to take. Alright, so let's take a look at what this means. So consider that expression, for example, this huge complicated fraction thing. You've got a whole bunch of things going on there. So taking a derivative of that, if I asked you to find y prime, that would be awfully difficult for you to do, right? Because there's just so much stuff going on in here. And you've got like a chain rule, product rule, quotient rule, and whatnot. So therefore, we're going to need to find some way to make that a little bit less tedious to solve, right? So that's where logarithmic differentiation comes in. It takes expressions like this and just makes them a little bit easier for us to solve. So that's the idea that we're gonna be following here. So let's do a quick recap of our log properties here. So because I mean you don't do logarithmic differentiation without logs, right? So let's take a look at some of our properties. And as a quick side note, I have a couple of videos about logarithms specifically on my channel, and I will link them to you here. So if you've forgotten what about logarithms and want a little bit more of a refresher there, then I'd recommend taking a look at that video. But for now, this is just a quick recap so you can see where you stand. If none of this makes any sense to you, then you probably want to go check out that video. So some properties. Log of a times b. Log of a product is simply a sum of logarithms. So log of a plus log of b, right? Similarly, the log of a quotient is log of a minus log of b. Okay, and last but not least, log of a to the nth power is going to be n times log of a. So here's the idea of what we're going to be doing in this video. So we're going to use the properties of logs to decompose complicated expressions into smaller parts. Okay, and then we're going to differentiate each small part. Okay, so that's what we're going to do. So we're going to decompose those huge expressions into kind of smaller parts, and then we're going to go ahead and differentiate them. Okay, so that's the idea of what we're going to be doing, exact steps for which we shall explore in just a second. So here's the steps as to what we do when confronted with logarithmic differentiation. So first thing you do is you take the natural log of both sides, and this is ln. And why ln? Well, this is just that it's an easy derivative, right? The ln of x is a very easy derivative to take. It's just basically 1 over x, right? So that makes our lives a whole lot easier. You could do log base 5 of anything, but then you'd have x ln of a. So that just makes things a little bit more complicating than it needs to be. When you take an ln, you just have 1 over x, which makes your life a lot easier, as you will see in just a minute here. So once you've taken the ln of both sides, use the properties of logs to decompose the expressions. Do this to the greatest extent possible. This is pretty important. So in many times you'll be able to use multiple properties of logs on any one expression. Do it as much as you can. Use as many properties as you can, because this is going to make your life a lot easier when you take the derivative, because you're going to have to use a chain rule eventually, and the more properties you can use, the fewer chain rules you'll have to use, and the easier your life will be. Okay, and once you're done with that, differentiate each piece. So the idea is here we're taking a huge complicated expression and we're breaking it down into smaller, more digestible bits that we can basically eat up or differentiate. All right, just one important note to keep in mind. Watch out for the left-hand side of the equation, all right? Because a lot of times you're going to have something like y equals f of x, right? So when you take the ln of both sides, you're taking the ln of f of x, that's for sure, but don't forget this ln of y you've got here. Don't forget it, because that is eventually going to yield another little thing that you're going to need to be aware of it, because when you take the derivative of both sides, you're going to get a 1 over y here. So you absolutely cannot forget that. So just keep that in mind, and yeah, just don't forget to take that into account when you do your derivative. It's really easy to forget once you're caught up in the excitement of what's going on in the right hand side, but just don't forget that you have this extra component over here that you'll need to take into account. All right, so the last thing we're going to do in this video is we're going to take a look at that example we saw at in the first slide. We're going to see if we can use logarithmic differentiation to deal with this. All right, so let's apply what we've learned. So step number 1, we take the ln of both sides. Okay, we take the ln of both sides, so this is going to leave us with ln of y equals ln of square root of 3x squared plus 3 over 5x plus 3, 2x minus 1 to the 10th. Right, so that's the ln of both sides. Now we can go ahead and break this down. So here's how that's going to be. So we have ln. So first thing we have to do is we're going to have to identify what's going on here. We've got a square root, we've got an exponent, we've got a product, and we've got a quotient. So what's the biggest thing that's happening here? Well, we have the biggest thing that's happening is the quotient, right? So we're going to start with the quotient. So we're going to go ln of root 3x squared plus 3 minus ln of 5x plus 3, 2x minus 1 to the 10th. Okay, so now let's see if we can simplify this any further. Over here, can we break this down any further? The answer is yes, but why? What can we do with the square root? Well, remember that the square root of anything is the same thing as taking it to the 1/2 power, right? The square root of anything is the same thing as taking it to the 1/2 power. So therefore, this is really, this thing right here is really 3x squared plus 3 all to the 1/2 power, right? So we can go ahead right away and bring that 1/2 to the front. So we'll be left with 1/2 ln of 3x squared plus 3. Now, can we do anything more with this? The answer is no. There is nothing more you can do with this expression. And it's a common mistake to make, to say like, oh, this is natural log of 3x squared plus natural log of 3. That is wrong. You can only write the log of a product as a sum. You cannot take a sum inside a logarithm and split that up. You cannot do anything more with this. All right? So just leave this as it is. And let's move on to this piece. So there's two things going on here. You've got the product, and you've also got this exponent here. So I'm going to deal with them at once. But before we do that, there's one important thing we need to remember. This negative sign is distributed to everything inside, to both components. Okay, so when we do a product, we're going to need to distribute it to both sums. All right. So let's keep that in mind, and let's move on. So this is going to be ln of 5x plus 3. All right, that's nice and simple. Since we distribute the negative, this is going to be really going to be minus ln. Actually, I'm going to bring the 10 down right away. This is going to be minus, we bring the 10 down, this is going to be minus 10. And don't forget, the minus is just because we're distributing that minus over there. So it's going to be minus 10 ln of 2x minus 1. Okay. And yeah. And all this is going to equal ln of y. Okay. Now let's go ahead and take our derivative. So if we take the derivative of everything with respect to x, on the left hand side we're going to land up with 1 over y dy dx. Okay, And again, that 1 over y is the reason we have to pay attention to the left-hand side of the equation. We can't forget it. It's going to equal, we can leave that, we can keep that 1/2 out. And this is going to be, we're going to have a couple of, as you can see, we're going to have a couple of chain rules here, all right? So, and that's again another reason why it's so important to simplify. Like having a chain rule with a square root is, it's easier granted than that, but it's still annoying. So that's why we wanted to simplify by bringing out that 1/2 power. So this is so much easier. So again, but we still have the chain rule, don't forget that. So this is going to be ln, so the derivative of ln is just 1 over x. So we're going to have 1 over 3x squared plus 3 times the derivative of what's inside. So that's going to be times 6x minus the ln of the derivative of the natural log of 5x plus 3. That's going to be 1 over 5x plus 3 times 5, or the derivative of the inside, minus, pull out the 10, so you've got 1 over 2x minus 1 times 2, or the derivative of the inside. Okay, so let's go ahead and just put all of this together. So we've got, on the right hand side, we've got 1 over y dy dx is equal to, so let's do some simplification. So the 1/2 and the 6 are going to cancel out. You're going to be left with 3. So this is going to be 3x over 3x squared plus 3 minus, so the 5 just goes on top, you can't do anything there, 5 over 5x plus 3 minus 10 times 2 is going to be 20, so we're going to have 20 over 2x minus 1. Okay, but are we done yet? The answer is no, we're not done yet. That's because we still have this 1 over y here. But the convenient thing is that we can just go ahead and tag on the y over here. So we can, if we multiply both sides by y, we're just going to end up with this y over here. Okay, so we've got that y over here. And now if you wanted to be super clean about this, so actually wait, that's going to be our final answer right here, by the way. Right, so that's your final answer. Now if you wanted to be super tidy about this, you would take this function right here and plug it right back in here for y, if you wanted to be super tedious about it. But I'm just going to stop at this point because you see what's going on, right? We use the properties of logs to break down that expression, to make it, to put it into smaller pieces that we could then easily differentiate. Like those derivatives, like those 3 derivatives were nothing compared to what it would be like to take the derivative of that, right? So these 3 would, this was really simple to do. So that's basically the concept of logarithmic differentiation. We're using the properties of logs to make derivatives easier for us to take, right? And sure, you have that y over there, and you could eventually tag on that expression, but the big thing I want you to get from this is this general idea of what we're doing here, right? So that's all I got for this video. I've got another practice problem video for logarithmic differentiation coming up right after this, so stay tuned for that. So that's it. Thank you so much for watching, and take care.